So let's go ahead and get started. Let me once again welcome everybody to the first of 3 webinars showing what's new in SolidWorks 2016. My name is Darin DASI, and I've been with DASI Solutions for just under 20 years now. I've had the privilege of working for a fantastic company and representing really game-changing product when it came out, but I think all of you can agree, a very easy, very fun, and just amazing piece of software called SolidWorks. A long time ago, SolidWorks started a design contest during our our SolidWorks World Conventions, and I won the first one back in 2000 and another in 2008. Actually, a couple of my other colleagues, John MacArthur and Ryan Cole and Sean Bentley, have also placed and won Model Mania over the years. So you are backed by a very, very devoted and skilled technical staff. I'm also a husband and father of 2 little girls. Addison will turn 9 next week, and Kennedy is 6, and I have 11 chickens, due to have 10 more arriving in just under a week. So let's get right down to why you're here. These are our 3 presentations. They're going to be in consecutive Fridays, so feel free to come back next Friday and the Friday after for part 2 and 3. But today we're going to focus on part 1, which will be the user interface for starters. Quite a few changes there that we'll discuss. We'll also get into sketching. I love showing this because it's the first thing we ever did, and it gets enhanced to this day, 24 releases into the product. Then we're going to move on to some part modeling functionality. So down here at the bottom, what we're going to go ahead and see is the thread tool, and then sweeps, which are very similar to the thread tool, but the thread tool being a purpose-built function for threads. We'll get into patterns, a little bit of surface creation, and some of the new spline tools that we have in the software, as well as our fillet tools, and then a new functionality added to our Intersect tool for finding internal volumes. Great little piece of software code. So let's go ahead and get started with our user interface. Now, for most of you out there, we are right in the wheelhouse of the most common upgrade time, which is Service Pack 3. In fact, Service Pack 3 went fully live yesterday. So Service Pack 3 has some neat enhancements in it relative to this user interface change, and I'll detail those at the end. But we've changed the user interface a bit just simply to deal with a lot of the things that are happening technologically. The graphics themselves are something that needs to be a little bit more flexible because there's a lot of high definition monitors out there. These 4K and 5K monitors have very tight pixel densities, and we've changed the interface to go ahead and accommodate for those with vector-based toolbars. And as a result of that, we also decided to change some colors and add some consistency across the entire Dassault Systems product line. I'll show this quite a bit today, of course, and really once you get into it, whether you're a seasoned SolidWorks user or brand new to the software, you should be very comfortable with that within just a few hours of using it. Let's just go ahead and get started looking at SolidWorks. So here we have SolidWorks 2016, and of course you can see the color changes that we have across the top. This is something, again, I'll detail as we get going. Now, for a lot of users out there, you've had situations where you're modeling quick and you're grabbing buttons and accidentally pick and drag, and this type of a thing happens. And that's our command manager getting detached. Now, frankly, most people get used to this and leave it in one particular spot, so this is a fairly annoying behavior. Well, first of all, if you try to do that across tool buttons, it actually doesn't do that anymore. So there's one little safety net added to it right there. But if you want to, you can grab the tabs and drag those out. However, up here to the top where we go to our settings, if you go to Customize, there's a new checkbox here that allows us to lock the command manager and toolbars so that that'll never happen again. So if you're not a fan of moving those ever, simply check that box and you'll be all set from this point on. Now, the interface itself has another really fantastic addition to it, and I'm going to go ahead and focus on this by collapsing my feature manager for starters here. And the tool itself is called Breadcrumbs. Now, it's a new way to interface with the software, but really it becomes a very comfortable way to get to the details of your features without really having to sift through the feature manager in more of a traditional method. So if you go ahead and select on any part, what you're going to notice here is the normal context-sensitive menus that pop up, but also over here in the upper left-hand corner is the breadcrumbs. Now, whether the feature manager is showing or not, it's still going to go to the upper left-hand corner of the graphics area. But essentially, that's going to go ahead and pop up right in that area no matter what you do. Now, as I select this, what we're getting here is a hierarchy. So what we see here are faces, features. The features have their sketches buried beneath those. And then the body, the part that's part of that face. And then the assembly and potentially a higher structure here of subassembly structures. Now each of these icons will give you the toolbars or the buttons that you would see by selecting these features in the graphics area. So by clicking on this face, I get options for opening the part, editing the feature, potentially editing the sketch if it's a single sketch extrude, and then the other options that you'd see for hiding and showing. When you see the feature here, the feature actually has the sketches nested beneath those that you can see highlighting on screen as we go across those. And then really great part here is that the part shows the mates, and those are all going to be nested above there. So very quick access. Now when I go ahead and select this, I'm not a big fan of the convenience or the inconvenience of having to go to the upper left-hand corner to grab this. So they've also built in the D key. Now this is just a hotkey like anything else, but if I tap the D key, which is pre-programmed, it'll actually bring those breadcrumbs to your cursor position. Now with that, I can go ahead and action on anything I'd like, even scroll through the sketches if there's more than one, and to select it, simply go ahead and edit that. Now by making a change to this feature here, we'll just bump that up to 20. Now I have to exit my sketch, which in the upper right-hand corner, we have our confirmation corner. Well, the D key will also bring that directly to cursor position. Now you can again set that to anything you'd like, including a button on the side of your 3D mouse if you'd prefer. But essentially that's going to work on anything in those tool areas. Now I'm editing a part within the assembly which I need to exit. The D key will also bring that confirmation corner over to cursor position. So it is really very convenient, gives you great access to a lot of details, and you'll see that throughout all three parts of this presentation, but quite a bit today. Next thing I want to focus on here is my section plane tool. Now the section plane tool isn't really what we're talking about here. It's more or less the triad. That's what I wanted to focus on. This is something that's really needed a nice visual upgrade. Before it was a red, green, and blue axis, and it was okay, but when you'd hover over any one of the axes there, they would just highlight a little bit better. But it wasn't terribly clear as to exactly what you were highlighting on. Well, here when you hover over these entities, it's very, very obvious exactly which entity you have control of. So if you want to reposition your section plane, that's great. If you want to grab the rotational ring and move it, again, very easy to figure out what you're going to do with those particular features. So love that new feature there, Rick. Now we've created a section view here, and I've actually done this to emphasize the situation that we have, and that's a bit of an overlap here. Well, to take care of that, what I need to do is modify the mates of the part because we see the same types of issues down here. Well, this is where breadcrumbs, again, are very, very convenient. By selecting the component and really not even worrying about the depth and the hierarchy of the feature manager, I can tap that D key and bring those breadcrumbs right over here and see that we have faces, features, and then the part with all of its mates right here conveniently located. Now I can actually click the mates and action on those. So when I go ahead and actually edit the feature, this gives us the opportunity to switch things up. Now right now I don't want to use any of these faces. In fact, I'm going to change this completely. And one of the behaviors that we have now built into assemblies by default is that when I select the face of a part, the first face of the first part I select will determine that part to now go transparent, which makes it incredibly easy now to select through to grab faces that were otherwise obscured by the current position of those components. Now I've had customers ask me if we could turn this off. You actually can turn it off. I don't recommend it necessarily, but if it's something that just bothers you or you're not used to or going to take advantage of, then feel free to. It's actually at the bottom of your mate tool. If you look right down here, there's a checkbox that says make first selection transparent. Now by deselecting that, that'll be a persistent setting on your system, and you won't have to worry about setting that once again. But I kind of prefer this, and you're going to see that a lot, especially in part 2 when we cover assemblies. Over in the Feature Manager, in SolidWorks 2015, we added some feedback when you'd hover over a feature. So here, if I hover and pause, we're going to see an arrow indicating the parent features of this part. Let's just bring this tool out a little further. What you're seeing here is what 2015 did, which was only the parents, actually. In 2016, we've added the children to this list. So I'm going to scroll up just a little bit here, and what you see are arrows going very high up the tree. They're indicating references to features, parent-child relationships to features that are very high up in the tree. The one just above it shows sketch 51. Well, that's only because that sketch is buried underneath that cut feature. Now, if I have that feature exposed, you'll see the arrow shows the indication of the reference, but not necessarily having to name it since it is visible within the tree. So these are parent-child relationships, essentially giving you an idea of what a change to this feature might do downstream, or that this feature would be driven by changes up above it. Now, if you don't like this to show up, it really only happens when you pause anyway, so you're not going to notice it unless you stay there for a brief second. But you can right-click on the name of the part or assembly at the top of the tree, and there's actually reference buttons that you can turn on and off, So if you like part of the feature or none of it, feel free to deselect either one of those. The last thing I'm going to cover on this little demo set here is the selection tools. When you select a lot of entities in a feature, in SolidWorks 2015 and previous, this box would stay a fixed size. Well, here it automatically gets larger. In fact, this is what you'd see in 2015, which if you had selected 1,000 things, you can see them 4 at a time, but that's about it. Well, here this will not only allow you to change this, but if you double-click the scroll bar or if you right-click within this window, both of those will auto-size this. So as I expand that out, you'll get to see a complete comprehensive list of the selected entities for this feature. Now I want to leave this particular demonstration set by going back again to what I said about our toolbars here. The toolbars themselves were in an effort to really standardize for more of the community as we grow. And as we've reached 3 million users, a good deal of the community has issues with particular colors when it comes to colorblind. And green and reds are the particular offenders in those situations more times than not. So we flatten these out to be these more blue colors. Now a small group of the population, although large enough size because we do have a large user base, really didn't care for those changes because of their comfort level, and we understand that. Well, SolidWorks developers time after time have proven that they are responsive to customers. In fact, very responsive, not just to their needs, but also timeliness when it comes to those needs. Now, Service Pack 3 was released yesterday, which I have not installed yet. However, when we're talking about Service Pack 3, the developers have made arrangements for the ability for you to select options to set back to previous or what we would call legacy or classic colors. So if you're not really thrilled with the different color changes, you will have options with Service Pack 3 to be able to go back. However, I would recommend you give it a chance because it is very easy on the eyes. You really don't think about it much once you start getting through it, but everybody has their own preferences. So both ways are going to be there, and feel free to use whichever is going to keep you the most productive. Next, I want to talk about sketching. Now, this one I love because, again, sketching is one of the first things ever created back in 1995. However, it's not immune to improvement. There's always suggestions that are going to make these tools easier, faster, and just better for the user experience. So keep any suggestion you have coming. These are the kind of things that just make the software better for everybody. And again, no suggestion is really any more or less important. If they're going to make things easier or better access or simpler workflow, it's just going to improve the user experience for everybody. So we're going to cover the selections of midpoints, something that has been, not difficult, but more clicks than it needs to be over the years. And then Instant 2D. Now, for those of you who don't use Instant 3D, this might be completely new, and we'll be showing you the behaviors in the new Instant 2D function. But Instant 3D has actually been around since SolidWorks 2008, and it's a great way to get quick access to dimensions, to modify those, and to not have to go repetitive clicks for things like rebuilds and editing dimension dialog boxes. Now, the other thing that we're going to cover on this one, and I'm going to do a little webcam here stuff as we go through this, but we're also going to deal with some of the sketch functionality that we have when it comes to editing. Many times in the software, you really have had no choice but to delete and redo entities, and a lot of times that has an adverse effect, especially when it comes to how relationships trickle through the feature tree. So reversing sketch dimensions, this thing that we have down here that allows us to access dimensional points and let them go, those are some things I'm going to show here that will give you the ability to edit things fully without having to delete and redo things, which again is a potential risk when it comes to how relationships trickle through the feature tree. And last, we'll finish with some convert entities functionality, which is fantastic. So let's move over to the demo set. So on this particular one here, let's go ahead and focus first on this valve body. Let me open up that file here. Now the first sketch that we've got going right here is a pretty basic sketch. Let me just go ahead and we'll get rid of Instant 3D Preview here for a second, so this will look nice. Sketches can get pretty hectic. This one's fairly simple by many standards, a lot of linear entities, but that's about it. But when you get all the dimensions here, and especially the sketch relations showing, that can clutter the sketch pretty quickly. Now I have a hotkey that I've created. It's just Alt-S, and that allows us to hide and show the sketch relations. I like them when I need them, but I really don't want them there all the time. So feel free to do that anytime you'd like. But what we also have now built into this version of the software is the ability to actually hide the dimensions while we're actively editing the sketch. So if they're in our way, we only need to see fully defined, underdefined, overdefined color feedback, then we can get rid of those easily. Now I've chosen to place those on my gesture ring, so you can see that I can hide and show those just with a right click and swipe up but it's also under your heads-up visibility toolbar. Just go about halfway down on the right, and you see View Sketch Dimensions as the option. So turn that on or off. Down here in the bottom, I want to access a midpoint to an entity. Now this used to take a right click to grab it. Well, now when you hover over the entities, it's really just a regular click. When you hover over something, it dynamically imprints, it highlights, and allows you to simply pick and select that. So I can easily select a midpoint with a single click, another point with another click, and a control key, and we'll just go ahead and make those vertical to each other. So very quick access to midpoints on any entity. Right here we have a line that is clearly not horizontal, and I'm going to use my quick tools to make that happen. So by selecting this entity, we're prompted with the types of relationships that would be appropriate. Well, this toolbar no longer goes away when you action on it. So if I choose to pick horizontal, I can still now stay in this box and pick some other operation to action on that line, like maybe convert it over to construction geometry. Or now in 2016, you can pre-select entities and go to your dimension tool. And what will happen is that it will then add the dimension after the fact. Now it also re-showed my dimensions because of course I can't add a dimension if I can't see it. But the workflow on this, and I'm going to exit my dimension tool to demonstrate this, is that if I was to pre-select entities, so here we have two lines not parallel, then I go to my dimension tool. What it will then do is give me a nice angle dimension to show me what that looks like. We'll place that, excuse me, and we will put the text in properly. Now I mentioned a new function called Instant 2D, and once again, a lot of people that I've found don't use Instant 3D. Well, if you go to my Twitter handle or you hit our DASI Solutions YouTube page, you'll actually see a 2-minute video that I've got on there about how to use Instant 3D. So go out there and check that out. But I'll demonstrate this by using the new functionality in 2016 called Instant 2D. Typically a dimensional edit, whether you're in the sketch or double-clicking parts in solid mode and then editing those dimensions, it requires about a 5-click operation. Typically what happens here is you would double-click a dimension, 2 clicks there, change the value, and either hit rebuild now and exit or hit exit and then rebuild. Either way, that's a lot of clicks that we got to deal with. Well, now in SolidWorks 2016, we can use Instant 2D. What that does is reduces access time. All I have to do is single tap the dimension, and with that I can then type a new value, and by clicking off of it or hitting enter, that automatically rebuilds that dimension. So there's a lot of really great things that happen with that. Now it doesn't matter how you do this. It could be just a slow tap on the dimension, again type in a new value, we'll say 125, and then if I hit enter it's going to go ahead and do that rebuild. But what I like about it is the dynamic access that we get. Here if I pick on the dimension itself, you actually get the endpoints, the open degrees of freedom on the extension lines of the dimension for that value. And I can actually grab that handle and drag it around. Now this dynamically works here in 2D as well as 3D, again since 2008. Now it's a very arbitrary value if I'm dragging this in this method, but you notice the scale that pops up. If you actually hover over that scale, it will snap to the lines, it will snap to those increments. So I can very easily grab a dimension, grab its handle, and drag it to a specific value. So it's both the freedom of drag and drop, but with the accuracy of having physical dimensions available to you. So it's really a fantastic way to be able to interface with your sketches. I'm going to use my D key here. We're going to exit that sketch. Now up here on the top, we actually have a feature that was created using a cut. And I'm going to edit the sketch of this feature because I want to show a change that was made to the software. Here we have an offset sketch. Now that was created by picking this face and simply using offset entities. Now if you didn't know how to use Instant 3D, you didn't know there was actually a way to be able to reverse the direction of this dimension by dragging it around. Well, regardless of whether you knew that, we have a function now that allows me to take this sketch, pick on the dimension, and there's a radio button over here that allows us to simply say reverse direction. That will take the sketch offset, it will flip it to the opposite side, and now if I go ahead and exit this particular feature, that's going to go ahead and give me more of a spot face in there as opposed to more of a grinding operation that it did before. But the point here being is that when you offset entities from an edge of a face, you have the ability to edit and reverse those instead of deleting and redoing. Now down here in the front there's a specific issue here, and I tried to lay a little groundwork on this one, but most of you really weren't aware that it was happening. When you look at a sketch here, especially with the relations on, we see things like horizontals, verticals, and equals, and tangent, and all these great relations. But you've never seen an icon at where two lines come together, where their points actually are coincident with each other. There's no relationship here. So in order to detach these types of things, you'd actually have to delete this line and then draw a new one in if I didn't want it to be linked to this endpoint. Well, now to avoid delete and redo, which again is a potentially hazardous thing when it comes to relationships and updates, you just simply have to right-click on a sketch entity, and there's a new option that's going to show up there called Detach Segment on Drag. Now what happens here is similar to Instant 2D. You get a couple of endpoints on that line that now show as purple. The one that I grab will let go. The one that I leave will behave as it normally has. So here I'm just going to simply pick that purple point and move it around, and you see that the other lines come together properly coincident to the center of that circle. Now I can easily reattach this to somewhere else, and I didn't have to delete and redo anything. I just had to simply have it let go of what is essentially a merged point. It allows me to then detach it and move it somewhere else. So that's going to save a lot of trouble, again, when it comes to those situations where a lot of people didn't realize you draw a rectangle, the corners of those rectangles don't have relationships. They are merged points, and there's no way to detach those aside from trimming and getting those things out of your way. Now up here on the top of the part, I've got a couple of hole wizard types of holes. This one's a counter bore, which we're going to go ahead and edit. And with this edit operation, I want to show you down here that when you switch from a type of hole to another type of hole, generally what's happened in 2015 and previous is it resets. It goes to the baseline of whatever hole you move to, and then you start settings from there. And that's inconvenient because obviously if you've set this thing up to be one hole type and you want to go from a counter bore to a countersink, you're really starting over. Well, now what happens is it keeps those values. So here I'm in an M24 hole, and if I switch over to a tap from a counter bore, what it's actually going to do is keep it an M24 tap. So that's a real great convenient part of this workflow. Now where it becomes even more powerful is when I edit holes like this one here that have custom values. So I've offset the outside of that a little bit more than the normal setting, and then the depth has been modified. Well, now when I go ahead and switch this to a different hole type, it actually recognizes this and says, hey, you've got some custom values. Would you like to keep them, or would you like to reset them? So by keeping them, any values that are common from one hole type to another, in this case only the one from the counter bore and the tap, it's going to retain that value, and you no longer have to make a note or a little sticky jot down to figure out what you need to type in when that hole resets on you. On the end of the part, we're going to finish this piece here by utilizing the hole wizard, but that's not generally the feature I'm talking about. I'm actually going to go ahead and refer to a feature we put in SolidWorks 2015 that's called the segment tool. Now I'm going to use the hole wizard to illustrate this. When you're dealing with a hole, this is a really great use for this tool, so it's great overlap. I want to put some positions in for some holes. Now to do that, I usually choose to draw a circle. Now this circle is not going to be very mystical. It's just going to be a circle at a given diameter, and then we'll just quickly go ahead and set that to construction. But what I'm going to do is I'm going to utilize the circle and the new segment tool and the way it behaves in 2016. Now the segment tool has two functions. You pick sketch entities like a line, a spline, circle, whatever it is. And when you click on segment, you can do one of two operations. We can either chop it up into equal size sketch segments. In this case, they would be co-radial arcs. They would be equal to each other. Or you can simply place points that are at equal distance along that entity. So even on a spline that's a very arbitrary curve, it's going to position those in a very nice equidistant path. Well, here we can go ahead and obviously change the numbers of them. And when we put it in, this is where 2015 ended. It put them coincident and left you at that point. Well, 2016 does it one better. It creates these points, but it actually creates a new relationship here called equidistant. If I try to move one of the holes points immediately, you'll see that they all maintain their spacing. And that's a really fantastic addition to this. Not only does that happen, but if I was to take one of these points and delete it, you'll notice that the rest of them are still equidistant to the remaining, therefore they respace. Now, that's a great addition, but editing has to go both ways. So if you right-click on that icon for equidistant, there's also an option that says Edit Segment Points. What that'll allow you to do is go back into the Creation tool and modify the number if necessary. So if I want to bump that up to 8, I can easily go ahead and do that, and maybe even drag these points around and snap them again. But it's great smarts that's added to this. You can see the relationships of coincident and equidistant added to those points, and it really works very well once again for things like our hole wizard. So once I get out of that feature and say OK, they will maintain their equidistant status throughout the design. The last thing I want to do with this demonstration set is actually go back to the assembly. And I'm going to build a gasket right in this area. Now I've got a part that's already there and in place, and it's blank, but we're just going to go ahead and edit the part and start a new sketch. So on this face, we'll begin by making a new sketch. Now my go-to tool, my absolute favorite, most powerful sketch tool is Convert Entities. This tool will grab all of the edges of the selected face, it builds a fully defined sketch, and essentially duplicates the entire effort but creates a very smart and referencing sketch. If the face that I chose to define it with changes, then my sketch will update right along with it. Super powerful, very easy. But it's always had one flaw. When you click a face and hit Convert Entities, it only converts the outside edge. It's never converted the inside edge. Now there is a method that if you pick the face and then Control pick one of the inside edges, it would actually focus on that inside edge. But in this case, I actually have 4 internal loops. Now this is a simple example. I could have 50 internal loops. It's always only done the outside of the face. So now what you do is instead pick Convert Entities first. Now over here in the window, it's going to show you what we select. So if I go ahead and pick the face of the part, you'll notice that it only gets the single face, therefore it would convert the outside edge. But the button we're looking for is this one right here. It's called Select All Internal Loops. When you click that, it will actually see my pick list increases to now have 4 additional edges, which is exactly what we need. And that's going to allow us to go ahead and take this sketch and in one Convert Entities operation, now go ahead and simply extrude it with a nice nested contour and an internal and an external edge to that. So that's now driven by that face, and if anybody updates the pump housing sketch, the first one we were just editing, then this gasket would then update its design right along with the change of that face. Really powerful stuff. That tool has definitely been necessary and is a great addition to this release. So we went ahead and talked about sketching and the access to midpoints directly, and then a new behavior for the interface called Instant 2D, which is a lot like Instant 3D that we've had for a while. We reversed the sketch dimension by picking the dimension and editing a radio button over in the Property Manager. And then we used the Segment tool to create equidistant points, in this case in the whole wizard, but it can be used for a variety of operations. Convert Entities, big addition here, handles the internal loops. That's a big, big addition once again. So let's move over to the Thread tool. The Thread tool is one of those things that has mixed reactions. And the reason I say this is because threads are one of the single largest performance hits that you're going to see in any CAD system. A helicoil sweep, that's a lot of compute happening. And putting threads on parts, especially unnecessarily, is just going to simply hit your performance. But we live in a new day and age these days. We have 3D printers, we have lots of digital manufacturing capabilities, and for those parts to come off the printers with threads, those parts have to be modeled with threads. Now it's not just threads. You'll see a custom example of this as well. But threads are one of those things where if you need them, and if you don't, avoid them just for performance sake. But this tool will really increase the workflow is to create these threads. So we're going to talk about using regular threads and then how we can customize these profiles to make really anything to suit your needs. So the first thing we're going to do here is we are going to take this shaft, we're going to add some threads to it. So let's just go to that one in its own window. The Thread tool has its own button. It's right up here in the top. And if it's not there, go to your command search and just type a little bit of the word thread, and you'll see that tool pop up. You can add it just by picking and dragging it off the command search, have as many of those thread buttons as you'd like. To execute the command is very simple. There's only 2 real inputs that you need. You need to know what your profile is going to be, and that's just a setting. We'll talk about that as we go. But the thread location is the main thing. Here it's really prompting you for a cylindrical edge, and that has a twofold effect. When I pick a cylindrical edge, it not only locates the tooth profile, but it also auto-detects the diameter. So I can put this particular tooth profile on any diameter shaft that I choose. The next I want to do is go my distance. That's going to be either a blind arbitrary distance, or what I prefer to use in this case is the up to selection. And when I pick this face, that's going to trigger my thread preview, and you'll see that immediately. Now, a couple of other little housekeeping things I like to do is you've got some control about where that thread starts and where that thread ends. And to make sure that this model shows up properly, what I want to do is just push this one direction and the other a little further. So by offsetting it, I can actually change where those entities are going to start and end. So in this case, I want to offset that more into the channel that we cut for the sake of making sure that we don't have a burr on the end of those chamfers. What I also like to do is offset this out into space a little bit more, again, to make sure that the tool clears the end of the part and we don't end up with a little burr out there. When that's done, though, we just simply say OK, and that is enough to create a fantastic thread. Go ahead and create an STL file, print this on whatever manufacturing device you've got, and print the opposite part with the hole, and these things will thread right together beautifully. Now, because we're using up to end conditions, we've built in a little bit of smarts here. So by picking on my part and by picking on the length dimension here, we're just going to modify that up a little bit. Because the thread goes up to the end of that shaft, by simply lengthening the shaft, of course, we're going to get an associative update. Now, a little bit of the meat and potatoes of this thread here. We're going to go back into the feature and just edit it for a second. When we're editing this feature, what you're going to notice is a couple of other things down here at the bottom. We have the ability to say whether we're cutting or whether we're extruding. Now, the reason that is because the tooth itself is only based on a direction. So when I see metric die as my list, you're going to get the software and it's going to automatically have inch tap, inch die, metric tap, metric die. And of course, you see I have a few other folders here for my customized versions. But by switching from die to tap, it really just means in versus out. By going from die to tap here, you'll see that it would then model an external thread. Now, in real life, you've got a hole. The only way that you can get threads in a hole is to remove material, and that's why you're going to have a tap. Well, on a shaft, the only way to get threads is to also remove material in real life, and that's by throwing a die on there. But here, since we're modeling, we have the ability to choose whether we're adding the threads to the outside of that diameter or cutting them to the inside. Or in this case, if this thread profile happened to be in a hole, this is the direction we would need to cut it into the material. You want to make sure that if you're adding the material, you switch to extruded thread, and then that will go ahead and make it a boss instead of a cut feature. Now, these can be customized. The tooth profile that we're talking about here is nothing more than a library sketch, the same that you would use for weldment profiles. So when we get into a different type of a component, maybe something that's a little bit more customized to the use case, this isn't a situation where I need threads. In fact, in this situation, what I need to do is convey material. So here I'm going to take this roller out of the middle, and we'll do the exact same operation, but using a different profile. So by using the thread tool, I'm going to switch up to one of the ones that I've created here, which is called a feed screw profile. Now, I use the same inputs. We pick the circular edge of the face. You can see that the feed screw profile was actually pre-located. And then we pick the up to, which is going to be this end face. And that creates a fantastic representation of this. Now here, it's actually set to cut, so I want to make sure that I add the material to this part. But what I also want to focus on the fact is that these library sketches are configurable, and in weldments too. That was a couple of releases ago. But this is one single sketch that actually has several sizes available. So if I want to make that larger, I can quite easily. And even if I want to reposition it based on where it auto-located, we can tweak those values as we go as well. So there's a lot of this stuff that happens that allows us to go ahead and use any consistent profile here and modify that as needed to increase or decrease the size of what we see. When all is said and done and everything is set properly, we just simply accept that and we get a beautiful helicoil thread, or in this case, a nice screw conveyor with millions and millions of triangles to make your video card happy. So use those where necessary, but again, don't overdo it. Don't do it just because you like the way it looks. You are getting a performance hit by having this type of a display and this type of a compute-intense feature. Now, going a little bit deeper into just sweeps as a general concept here, I want to show you what has really been a great addition here is something called circular profiles. Now, we realize that about 85% of the time when a sweep is done, it's usually a circle. It's done for a spring, it's done for a hose, so there's really no need to create that extra geometry for something that is, more than not going to be the usage case. We also have the ability to edit these things more proactively with the reference curves no longer being absorbed. And then sweeping, well, it really doesn't matter where you place your sweep profile anymore. So let me show you those. We're starting off right here with just a basic set of curves. Now these curves were generated by using a helicoil and then actually taking a couple of 3D sketches, basic flat sketches, but in 3D space. And then those 3D sketches were all put together with that helix to create this composite curve. So it's now joining all three of those. Now what we're going to do here is make a basic sweep. But once again, I've not created a sweep circular profile, which is typically on a plane out there at the end and located properly. Here we just say instead of using a sweep profile, we're actually going to use it as a circular profile. Just make it a circle. You just tell it what the diameter is. All we need to input now is the curve we're using to drive it, and that is it. No longer have that extra entity located and pierced out at the end, and one more thing to potentially break if you do make a drastic edit. Now the other thing that happened here is if you look at my feature manager, the composite curve, the helix, and those two sketches didn't get buried underneath the sweep. Now that fosters two things. Usability, which means I can use those curves for other features without having to recreate or duplicate or copy in some way. But I also have the ability to edit those freely. In 2015 when we did this, this is actually what happened. Those features would get buried underneath the sweep itself. And in our situation here, we've actually got an area where that curve and the 3D sketch don't blend tangent. Well, to edit that, 2015, I would have to delete the entire sweep and then redo it after fixing the sketch entities. But here in 2016, because we're not burying those, I can actually easily go to the sketch. We can edit the sketch, and if you take a look at right here, those two aren't tangent to each other. So just by picking on that endpoint, or in this case grabbing the curve and the line, we can go ahead and make those tangent, which will update the location here. Now we didn't need to define a circular profile, so nicely enough, it just has a circular diameter as its driving value, therefore it updates flawlessly. Now this is a gotcha that really happens to almost everybody, whether you're again a new user or a seasoned user, and it has to do with where you position the profile when it comes to a sweep. And sometimes you really don't have a choice in this, it's just based on how the geometry stacks up. Well, what you get as a result in 2015 and prior is if I select my profile and I select my path, well now I realize that I'm in the middle of the path and I can only go one direction or the other. Well, 2016 adds this convenient button here called bidirectional. With that button selected, it doesn't matter where your profile is placed, it's simply going to go to the entire extent of your path. So that's not in the middle, it's bidirectional, so even if I placed it at about 30% of the distance along the path, it would still continue in both directions. Next I want to detail a little bit on patterns, and there's two nifty things here. First of all, the inputs for defining direction are now a little bit more open when it comes to linear patterns, but also there's some improved workflow when it comes to something we added in 2015 called the variable pattern, and the ability to use Excel spreadsheets to drive this. So let's just hop right into that. The issue with this part here is that there's not a straight edge anywhere on it. So to define a pattern, I'd actually have to create something, whether it's an axis or a sketch or just something to give myself directional input. Well, now when you do a linear pattern, you can actually use a cylindrical face or a flat face to define this. So by using a cylindrical face, it happens to give it a vector based on the fact that it's straight. And now when I go ahead and grab the feature that I'd like to pattern, we're going to see the preview that's necessary. So whether we're space changing it or we're moving the direction, that can also be done right there graphically just by tapping that little arrow right there. So that gives us a little bit more flexibility when we have parts that are very organic and maybe don't have the necessary inputs based on prior needs. On the back side of this part though, we have a really dynamic pattern here. It's a little bit of a stipple pattern, but it's what we call the variable pattern, and it's all based on a single thing. This sketch, it's a little slot, it was extruded, and then we put a fillet around it. We've actually used that as the seed feature to create this pattern itself. And what you'll notice is that the seed feature here in pink is different from the resulting feature. The reason that is because of the way the variable pattern functions. It is essentially a design table for patterns. You pick the input features here, which is just that grip extrude and the fillet, and then we pick some reference geometry if necessary, which helps us locate the subsequent instances. By editing the pattern table, what you'll see here is that we have a very simple table-based input, and it shows us the horizontal offsets. Right now, this one here is a little bit offset to the left, so if I update my preview, you'll see that those aren't right on center with each other. But by massaging one of these values here and saying 0 is my offset, when I update the preview, you see that that slides over to the right, and they're both on center. Now we also have the ability to add additional rows here manually, as well as through Excel. So when we have one selected down here in the corner, by tapping this button, it adds the number of rows indicated in the box. Now I'm going to add another value here. We'll use a negative number though. Here's one of the rare cases we do use negative numbers, where we can say negative, that's just simply a directional change. We update the preview and it now makes another instance now above it, 17 millimeters, as opposed to below. Also values can get changed here, and things are going to update there dynamically. Well, these patterns can get pretty heavy. You might have a lot more input than you'd like to do manually here, and that's where we now have the ability to import this directly from Microsoft Excel. When we grab this, it's actually more convenient, and I'll go back on this, to simply take what you've got here and export it to Excel first. If you export this value to Excel, then it's going to give you the formatted table that you can then modify using more formulas and other values there, and then import that table back in. So export it first. But what you'll get as a result of this, let me do a little navigation here. What you'll get as a result of this, though, is the ability to put in some very dynamic patterns based on how these Excel tables stack up. So we're going to go ahead and use this offset grip pattern for today's demonstration. When I put that in, it's simply going to populate my table. And when I update the preview, you'll really get a feel for how amazing this actually is. We can take one seed feature and make as dynamically changing and repositioning pattern as we like. One single pattern creates all of this geometry. We simply accept the values, and we get this fantastically dynamic feature all deriving from this one slot and one fillet right in the middle. We look at this part here, and it even maps the topology based on the input geometry being on a point that's coincident to this surface and a plane that's tangent to this surface at this point. Very ingenious method, very powerful result. So we did a little bit with linear patterns where we selected cylindrical bodies instead of just linear edges or features in order to drive the direction. And with the improved variable pattern, we can import things through Microsoft Excel and just get a lot more power at our fingertips to create more dynamic pattern tables using more things like formulas and concatenation and other Excel-specific types of capabilities. Now over to our last demonstration set, and this is where I'm going to cover the last three portions of today's presentation. We're going to do a little bit with surfacing to start, and surfacing really is driven by the new spline tools that we've added to the software this time around. Now with that, we're also going to get into a little bit of the workflow change that was added for surfacing. Reducing some of the steps is essentially where that one comes down to. We've also got a great functionality with fillets, and the fillet functionality isn't just limited to surface bodies. In fact, it's just the normal fillet tool that we'll be using. But for consumer goods, for really organic shapes and blends like you're seeing on the screen here, the tools have been enhanced in an incredible way here with 2016. And then last, I want to show the great enhancement to the Intersect tool, which allows us to very quickly capture the value of the internal volume of any type of vessel. So let's go ahead and jump into each of those. So we're starting off with what is a pretty common process for a lot of our customers that do product development. They start with an image. That could be a photograph of something they saw, could be a sketch or a mock-up like we have here from maybe Adobe Illustrator or Photoshop. But it's an art-to-part situation where we want to take some sort of maybe sales or marketing-based input and be able to create real geometry from that. Obviously, we've got the marketeers that are doing their job and the engineers that are then going to make it reality so the customers can benefit. So what I do here is generally I manually sketch around these. There are tools for auto tracing, but when you're given an image, the quality of that image has everything to do with whether auto trace is even going to work or not. And manual tracing isn't difficult. In fact, you'll feel a little bit more empowered with it typically. So what I want to do is I want to use this image, and I want to use this to drive a sketch entity. And I'm just going to do it by manually sketching a spline across the outside edge of this part to capture it. The spline tool that I use all the time now, and I really avoid the other ones mostly, is the style spline. This was added a few releases back and really gives you better input and control while keeping the spline more clean. When I choose the style spline, we now have additional values here in 2016 that allow us to go from a Bezier curve, which is the only way we could do it before, to now using B-spline inputs. Now, without getting too technical on this, the B-splines here allow us to create curves that have really drastic changes in curvature, but remain very, very smooth. And that's always been one of the flaws of a Bezier curve, and input handles that you can change the inflection, direction, angle of attack, and weighting. This is a lot better method. So the way we do this now with the style spline is we use some construction geometry as the input. So I'm just going to go ahead and click and release. We'll move over here, and I'm just using my preview a little bit to follow this, but I'm actually going to change this quite a bit as we get going. So I've got a couple of inputs here. Let's just put a couple more out here, and then end this spline. Now you see my inputs here are all based on construction geometry. So as I grab these handles, we can drag those around, and they map to the topology quite readily. You can see that just by dragging these points around, it really allows me to change those curvatures nicely, whether I grab an entire line as I've done here, or whether I grab an endpoint that then is just going to modify that control point. But it allows me to do a great deal of manual control and manipulation to follow that curvature exactly as needed. Now as a validation tool here, if you right-click on any spline, you can go down to Show Curvature Combs. And what that'll do is actually show you the curvature and the inflection. Now I've made this a drastic input here with the scale so you can see this better, but no matter what I do, you'll see that we have these very nice curves. And even though it's going from convex to concave and then turning back, there's not these giant lines that are very abrupt adjacent to each other, which would indicate poor curvature. This is a beautiful looking spline here, no matter how you slice it. Looks great. So I'm going to go ahead and take that spline, and that's going to be my input for the side of this surface. So let's just go ahead and do that. Now once I finish up this sketch, we're now just going to go down halfway through this part just to show you the other surfaces that are built up here. And there's a few other things we don't need to see moving forward here, so I'm going to hide these. But essentially what we've now got is we've got this surface body that we used from sketch on one side to the sketch on the other. As I go down to the end of this part, there's a lot of other surface bodies that we've got in here. And with those surface bodies, what we're essentially looking at is a bunch of intersecting sheets. These are untrimmed surfaces, which any surface that you see, there's analytical geometry in the computer indicating how that surface extends out into infinity. But essentially what we see here is their pre-untrimmed raw form. Well, SolidWorks has always had some great surfacing tools here for manipulating imported data as well as created data that we made. And the trim surface tool is one that's got some great enhancements this time around. When you trim surfaces, I generally like to use the mutual trim. Now what that allows me to do is go ahead and select everything, and essentially every surface trims each other. So if two surfaces hit, one trims the other, and then the other trims the first. Well, then down here what you do is either choose what's easiest for you. You can either choose what you're going to keep, or you can choose what you're going to remove. It's really all about the least amount of selection set. So here I'm going to choose what I'm going to keep. Now as you select these, the pieces that you keep now disappear. So it filters what we're seeing on the screen to only the things that are left. Now it makes it very clear to see what we're going to keep on this part, but we also have some toggle options here that allow us to see what am I going to keep versus what's going away. Lets me know if I'm going to have a nice volume there. Or the opposite with this with a hybrid, which is going to be a faded version or transparent version of the removal faces, and then the yellow versions of the ones that we're going to keep. Now in addition to this trim operation, we're baking into most of the other surfacing capabilities a new option at the bottom that allows us to skip what is typically another step, which is creating a solid. If my trim operation here is going to result in a nice closed volume, I don't have to then do a knit surfaces that's going to create a volume or a thicken operation that then creates a volume. I can actually just say create volume right now and skip those features in the tree. When we accept that, we now end up with this very beautiful solid, very organic in shape, but if we take a look at a section view on that, you'll see that this thing does have thickness and volume on the inside. So down here on the bottom of this part, I want to go ahead and look at some of the edges that are there. And these two faces, of course, do not blend smooth. Well, what we're going to do here is just use the run-of-the-mill, most common fillet tool to round this over. And this is something that had a really extreme addition to it this time around. So by grabbing the edge, again, the most common fillet input, constant radius edge selection, we're going to start right there. Now what you'll typically see in any fillet selection is you're going to see a nice preview of that. But now with our common edge constant size fillet, you can change this now from a circular radius to something that is more parabolic. Now all the time a radius has been something that is just a round. Now if it's two perpendicular faces, we call it a quarter round, but it's like rolling a ball bearing between these two faces, and whatever that radius is would be physically round. Well, now we can change that profile to something more organic, which in this case is going to be curvature continuous. We added conic row and conic radius back in SolidWorks 2015. But curvature continuous now gives us Class A capabilities. C2 tangency, which is the two C's there, curvature and continuous. And when you do that, you'll see the profile actually changes to more of a parabolic or elliptical shape. Now with that, I can also go ahead and take this profile and change it from a single radius, we call it symmetric, to something called asymmetric. Now asymmetric very simply means I have a different distance in each direction. So I can have 10 millimeters going up the side and 8 millimeters going around the bottom, or even toggle those profiles and switch their direction. But no matter how you slice it, this fillet blends very slightly as it comes off of that face and then turns more drastically around the corner as it attacks this bottom face with another Class A blend. We say OK to that, and we get a fantastic blend between those two complex faces. Now just to really emphasize this, I want to come up here onto this, this kidney-shaped cut that we have. And we're going to do the same kind of thing. Edge selection, very simple. The only way to do Class A blends before would have been face blend fillet. But here we're just going to use not just a constant radius, we're actually going to move over to a variable radius fillet, which is really a fun thing to create. and it actually creates some incredibly powerful geometry. Now I'm only going to use single dimensional inputs on this, so we're going to go back to symmetric. But what happens with a variable radius fillet is that each edge initially gets up to 4 points that you can select for different diameters or radiuses. And you can add additionals, but 4 is going to be the ones that are there. And you can actually see those out there, these little tiny pink dots. Now they're not active currently, but if you click on them, then you get a handle out on the screen that you can change its position along the edge, as well as the radius at that point. And I'm going to go ahead and activate all 4 of these. Now I really prefer to deal with these out here in the graphics area just because it's easier input. We're going to leave this one as a 10. Let's go ahead and drop this one down to an 8 down here. And as soon as we have some values that are going to stack up nicely, we'll start to get a nice preview that shows up. So there we go. And let's bump this one up big. Let's go maybe up to 12 on that one. So you can see how this blend is going to happen. But again, we're going to do this as curvature continuous, Class A blending. Each of these points can then be repositioned if you'd like, and this is old variable radius fillet stuff, but now that's at 61% along that edge instead of 50%, but you have the ability to drag that around anywhere that you'd like. Once we say OK to this, now we're going to see where the blend actually comes in. Now here it doesn't look even as good as you might be able to vet, but long time we've had in the software the ability to check the way faces blend to each other by turning on something called zebra stripes. Now zebra stripes are akin to those horizontal or parallel light bars that a user would actually use in real life to maybe see the finish on a car or an automotive paint job or a consumer good and how it's going to look sitting inside of an office environment. Well, zebra stripes here allows us to see how these faces blend. Now when you look at zebra stripes, the key is that the zebra stripes touch each other. Now down here, they not only touch each other, but they blend smooth. By touching each other from face to face, that indicates a tangency. But by actually blending smooth as we rotate this around, that indicates a Class A tangency. Once again, if I zoom all the way out here, and this is probably pretty heavy on the GoToMeeting here, so I apologize for the bandwidth on that. But if we look at these ones up here around the handle, you'll notice the same type of effect there, is that those are blending very, very smooth. If we roll this around to the back side of the part, then it's very clear that those edges have a rigid transition from one to the other, and they're not blending. So those are great ways to be able to see how your part looks, but really be able to vet the quality of it as you're designing. Now this is going to be a picture. So what I want to do is take everything that we've got here, and we're going to go ahead and mirror the entire body. Nothing new here, means to an end. Now of course this picture is going to have to hold some liquid at some point as well. So let's just shell this out by removing the top face and giving the rest of it a millimeter of wall thickness. It's enough to take care of what we need here. So now what we have is a hollow body. And this is one of those circumstances where a lot of customers get into the need to see what the volume or the capacity of this vessel is. Now there's more complex examples of this that I can show, and I've got a 2-minute tech tip that's going to go up this week regarding hydraulic cylinders. But in this case, we just need to cap off a volume to go ahead and make this, this volume inside automatically. But we use the Intersect tool to make that happen. Now I've got a plane that's in my featured tree. This plane I've actually called fill level, but it's just in the position that I would figure would be about capacity for this thing if it's full of liquid. Now using that plane and going to the Intersect tool, we're going to use a new radio button here called Create Internal Regions. So we grab the fill level plane, we grab the body or bodies that are involved in this, and as soon as we say Create Internal Region, it automatically generates a solid body to represent the capped off area. So we are essentially building a solid to represent the air gap between the top of that plane and whatever is below that, sectioned off by our geometric bodies. Now what happens with this also is that it creates this body and it leaves it as a separate multi-body part. What that helps us with is the ability to actually check the volume. So by going to Evaluate and clicking Mass Properties, the default here is always the entire part file. So you see that we have jug, SLD, PRT. But if you select an individual body, it will then give you the volume for just the selected entity, which in this case is 1.95 liters. Now one little bonus instruction on this one is a couple releases back we added something called tab to hide in assemblies. Tab to hide meant if I hovered over a part and tapped my tab key, it would hide that part. Well, that behavior now works in multi-body parts. So by tapping tab here, I can hide and show these bodies as necessary. The way to get them back was to hold Shift tab and then just hover over where those bodies were. Now that's not very convenient because invisible parts are very hard to hover over because you just simply don't know where they are. So if I tab to hide these parts, I can now bring them back with a preview by not just hitting Shift tab, but by hitting Control Shift tab. And what that gives you is now transparent preview of the bodies that you might want to re-show. click on it, and they will simply reappear. But in the end, the mass properties of just the fluid is what we're going for, 1.95 liters. All you have to do is use planes to cap off the area, and as long as the air in the middle is sealed and there's no holes venting to the outside that are uncapped, you'll be able to do this in even more complex multi-body systems. So we started this part by using the new capabilities in our style spline and using B-spline inputs for improved curvature and smoothness along those really drastic changes. The trim tool has been enhanced so that it now has additional functionality with the convert to solid built in, but it also has great preview capabilities when it comes to what you're keeping and what you're throwing away. Curvature continuous fillets can happen almost anywhere. Now they can happen on regular constant radius single edge picked fillets or variable radius fillets. And then utilize the Intersect tool here for creating internal volumes. And this is a single part, but a multi-bodied part that represents a hydraulic cylinder with hoses and fittings is something I've got a demonstration going up on our YouTube channel here shortly for, so please check in with us on that. So I'm going to go ahead and move over to just check questions here and see if we have anything up. But again, we checked out the user interface today and the changes we have now and the potential to go back to the old colors if you prefer. So don't fear if it's a little too much for you to handle, you will have the ability to revert back. The sketching enhancements, once again, lots of those things. Keep your requests coming. Doesn't matter how long the software has existed. If you have a good idea, we're willing to put it in the product. It's just going to improve it for everybody. Workflow on the thread tool as well as regular sweeps have improved significantly. And then patterns give us better capabilities as well as more dynamic input capabilities with our variable pattern tool. Surface workflows as well as adding fillets and using the intersection tool on bodies to go ahead and capture that internal volume are again great additions to the workflow that we have here. So with that, let me go ahead and check questions, but we're going to start to end this here. And if you want to get more content like this, these videos we're posting up on our YouTube channels, and a lot of our technical staff are creating lots of content, whether it happens to be simulation based or SolidWorks electrical based or PDM based or even just SolidWorks. We're putting content up there regularly, so please do follow us on our YouTube channel. If you want to follow me directly on Twitter, please feel free to follow me at DG Hockeytown. That's Darin Grosser, Hockeytown. So let me take a look and see what kind of questions we have out there. And it does not look like we have any today. So that's good. I hope everybody is happy with what they saw. You'll be able to watch this either later today or early next week at your convenience, so that you'll be able to check out the things that we're doing here as you're working on those in your release. And I just want to thank everybody for the time that you spend with us. Believe us, it is not lost on us the value of an hour of several people's time to sit through these presentations. So we do put a great deal of effort into making sure that the content is valuable for you and is something that you can use and is going to improve your day. You always have the ability to contact us through tech support if you have additional questions. You can get a hold of me directly with the email address you see on the screen, or you can contact us at tech support, all one word, at decide-solutions.com. So with that, I'm going to go ahead and close off today's webinar. Thank everybody for joining us today, and join us again same time next week for part 2 of What's New in SolidWorks 2016 presented by Decide Solutions. Thank you very much.